Hello and welcome to this first tutorial on the ST software. This is a structural analysis software that can do 3D linear elastic structures. And what I'm going to do is that I'm going to analyze this structure. This is a very simple truss structure with a couple of loads, support conditions like this. So this is the simple problem that I'll do. This is also the simple truss example problem that is posted online, so I'm going to not create the objects myself in this tutorial, but I'm going to load it from the input file. So you can drag and drop, or you can go to File, Open, and open this file from wherever you have stored it on your disk. In this example, we have created some node objects. To create them, you may know that you right-click on the object you want to create and you press Create. In this case, I have pre-created a few nodes. One is called Node 1, so this is where you get the name. If you look at this pane here, this is called the Properties pane. You will see a number of properties of a node. The degrees of freedom can be free or they can be fixed. And you can see that one of the 5 kilonewton loads I've given here in the negative y direction. Here in this example I'm using consistently Newton and millimeter as units. If I go down to the elements, I don't have in this example any frame or four node quadrilateral elements, but I do have a few truss elements. So again, you can right click on truss to create them, but here I have pre-created them in the input file, and here you see the properties. It has a node number 1, node number 2, those are the end nodes. The elements, they also have some results. The axial force result so far is 0. At the bottom of the domain tree, and when I look at the bottom of the screen here, you can see there's a domain and there's an analysis. The domain is what contains all the data, and I have one cross-section with some properties only giving the cross-sectional area. In this case, I don't need the bending and torsion properties because there is no bending or torque action. I also have a material where I have given my Young's modulus and my Poisson's ratio, and that concludes the data for this model. On the analysis side, I need one solver to create to solve my system of equations. This is an LU solver, and I also need an assembler to assemble the stiffness matrix and the load vector, and this is a transformation matrix type of assembler. Those are the only options that you have available, and I'm ready to start the analysis. I go to Analysis, Linear Elastic, and I choose the solver that I have created, and I also choose the assembler that I created, and I press enter. And here you see a quick little plot of the structure. You'll also see that a number of nodes here, they were fixed because they had 0 stiffness. So in this case I modeled a 2D structure, and I didn't give any stiffness to the out of plane degrees of freedom, but that is detected by the program, and they are restrained by the software. You see one result in the output pane here. That's the maximum displacement or rotation, 1.5 millimeters in this case. But if you're interested in more results, you can go back to the domain, and I can look at element number 1, for example. That has now an axial compressive force of 5,000. Element number 2, same thing. Element number 3 has a tension force, which is positive here, of a little over 7 kilonewton. So that is how you can look at results from ST.